Hello everyone. So today we're going to continue on with solving equations. Today though, as you can see down here, we have the beautiful fractions that we're going to throw in the mix. And we're also going to solve what we call literal equations. Before we do that though, let's do a warm-up so we can get our brains a-pumping. So remember yesterday we wrote down that list of the steps of solving an equation, and the first step was to use the distributive property. So that's what I'm going to do right now. So now I'm still going to have this a negative 11. When I distribute that 10, I'm going to have a 10p plus 100. When I distribute this, I gotta make sure I'm taking the negative with it. So this is gonna end up being a negative 10p minus 55. My next step was to combine like terms on both sides. So on this side of my equal sign, I have a negative 11 and 100, which is gonna give me an 89. And on this side, my like terms, I have a 4 and a negative 55, which gives me a 51. Now I need to move my variable to one side. So right now I'm adding 10p, so in order to move it over, I need to do the opposite. So I'm going to subtract 10p from both sides. I need to do the same thing with my constant, move it over to the other side, so I'll do the opposite operation and subtract it. Ooh, this should be a negative 51. Because this, so that means I'm going to add it, my bad, sorry. And now right now I'm multiplying p by a negative 20, so in order to move it to the other side, you need to divide it. Which means p is going to equal negative 7. I could, of course, always check this as well by plugging what I think is my answer into the original problem. I'll do that over here quick. Oops. Negative 7 plus 11. So now in order to clean this up, I need to follow PEMDAS. So PEMDAS says I do what's in my parentheses first. So this is going to give me a 3. And I'm going to do my parentheses over here as well. Multiplication first is going to give me a negative 14 plus 11 is a negative 3. Go through and do my multiplication. So over here I have a 30. Over here I'm going to have a positive 15. Let's see, negative 11 plus 30 is 19, and 4 plus 15 is 19, which is a true statement, so that tells us we were correct. We did everything right. Yeah, go us. All right. As I mentioned then, we're going to be dealing with fractions today. And there's a couple different ways I'm going to show you. The first one, and it's pretty easy to do it with this one, is just to deal with the fractions as they are. So I would go ahead and distribute the 1/2 and the 1/4. So 1/2 times 2b is b. And 1/2 times negative 4 is a negative 2. 1/4 times 8 is 2, and 1/4 times 32b is 8b. And now from here, it should be a pretty simple equation to solve. So I'm going to subtract b from both sides. Subtract the 2 from both sides. Divide both sides by 7, and I'm going to end up with negative 4/7 as my answer. It was super nice to just distribute our fractions as it was this time, because when we did that distribution, we didn't have any nasty numbers in there. We got rid of all of those fractions. Sometimes, though, that's not always the case. So I'm going to show you a different way to deal with them. I'm just going to recopy down this original problem quick. So I just want to point out before we start, that's a B, that this is one term. Because of the multiplication, it makes it stick together. Just like this is one term as well. So now, in order to get rid of my fractions, I can multiply both sides and all of the terms by my greatest common denominator. So we need to ask ourselves, what number does both 2 and 4 go into? And that's 4. I need to multiply both sides and all the terms by 4. So I said this is one term, so we only need to multiply it once. And 4 times a half is going to give us 2. And the stuff in the parentheses is still there. Need to do the same thing over here. 4 times 1/4 is just 1. I don't need to write that because 1 times anything is itself. And now I need to do some more distribution. I'm going to subtract the 4b from both sides. Subtract 8 from both sides. And I'm going to end up with a negative 16 over 28, which looks a little different than what we got over here. But if you notice, I can reduce this answer. 4 goes into them both. 4 goes into negative 16 negative 4 times, and it goes into 28 7 times. And now you notice we have the same exact answer. Alright, let's try another one. Again, we have 2 terms here, one on each side of the equation sign. And notice here, once I do my distribution, I'm going to get some really ugly numbers. So I'm just going to multiply every term by my common denominator right away. So 3 and 6. 6 goes they both can go into 6. So now again, I only need to multiply it once because they're one term. So now 6 times 1/3 is going to give me a 2. And 6 times 5 6 is going to give me a 5. Do my distribution again. And end up with 14b minus 18 equals 40 plus 10b. I'm going to subtract the 10b over, add the 18, which gives me 58, right? Divide both sides by 4, and I end up with 58 over 4. But I can reduce that. 2 goes into both of those, and it'll become 29 over 2 as my answer. If I would have just dealt with the fractions and kept them nasty as it was, I would have gotten down to the same answer. Alright, let's do another fraction one. Ooh, this time, remember this multiplication glues us together, so here I have a term, here's another, and here's my third. I have 3 terms this time. So now when I think of my greatest common denominator, a number that both 5 and 3 go into, I'm coming up with 15. And make sure it gets distributed to all of the terms. A lot of people will forget to multiply it by that negative 7. So now when I do this, 15 times 4/5 gives me 12. Notice that what's staying in the parentheses is staying the same. 15 times 1/3 is going to give me a 5. And negative 7 times 15 is negative 105. I have some more distribution to do. And I'm going to end up with a 24x minus 12 plus 45x minus 10. I need to combine my like terms. Get my constant on one side. Right now I'm subtracting 22, so I need to add it to the other side. And now to get my final answer, I'll divide both sides by 69. And I'm pretty sure that we can't reduce that at all. So that would be my final answer, as ugly as it is. Alright, last one that involves fractions then. Notice this time we don't have any distribution that we have to worry about right away. But I do have 4 terms this time. And I also have 3 fractions. So now I need to figure out a number that both 4, 6, and 3 go into. And I think that number is going to be 12. Make sure it gets distributed to each of those 4 terms. See, 12 times 3/4 is going to give me 9. 60 minus 500. And I could use my calculator to do this, just 12 times 3 divided by 4, and that will give me that 9. Same thing with 12 times 5 divided by 6. And now I can solve it. I'm going to subtract the 9x over and add the 500. Divide both sides by 51, and I get, 51, and I get 10 for my answer. Alright, so then I said earlier, the second thing that we're going to look at is what we call literal equations. So this is actually the surface area of a cone formula, and they're asking us to solve for L. And we're basically treating like this like it was any other equation, so we need to peel back those layers. So the first thing I want to do is I want to get rid of this. So right now I'm adding it to both sides, or adding it to this side, so in order to move it to the opposite side, I need to subtract it. And now in order to get L by itself, right now I'm multiplying it by this pi r. So in order to do the opposite, I'll divide both sides by pi r. Pi's are going to cancel, r's going to cancel, and I'm going to be left with L equals s minus pi r squared over pi r. And that is my answer. It can be kind of tricky though because there's so many variables in it. So one thing sometimes that I'll do is I'll just put numbers in for the variables that I'm not solving for. So for example, I want to solve for L, so I'm just going to say S is 100. I'm just pulling that out randomly. I'm going to say pi r. I'm going to say that equals 5. Again, just making up numbers. And pi r squared, I'm going to say is 20. So now I'm going to plug these random values that I just set into this. So we said S is 100. We said pi r is 5. And pi r squared is 20. And now if I was going to solve this, well, we know we would just subtract the 20. And then I would divide everything by 5. And now that we have that, I'm going to go ahead and plug back in my my variables. So we said the 100 was S. We said 20 was the pi r squared. And we said the 5 was pi r. And if you notice, that's exactly what we got over here as well. Sometimes, being the mathematicians that we are, we like to do that math right away and call that 80 and then divide that by 5, which doesn't really help us at all, but if you can leave it like that, maybe it'll help you. Alright, the last one then. This formula is for the area of a trapezoid, actually. And they're asking us to solve for the second base there. So I need to peel back those layers. And the first thing that I want to do is get rid of this 1/2. I want to move it to the other side. And I can either do that by dividing by 1/2, or division by 1/2 is really multiplying by 2. So I can multiply both sides by 2 and get rid of that. Next thing I want to do is move this h over. Right now I'm multiplying by it, so I'm going to divide both sides by h. And now last step, I'm almost there. The only thing that's stuck to b sub 2 now is that b sub 1, and I'm adding it, and subtraction undoes addition, so I will subtract it from both sides, and that will give me my b sub 2. You guys have a worksheet due tonight. Again, I will post the answer key on Google Classroom as soon as I'm done with this. And you guys also have a quiz tomorrow on solving equations. The quiz will take place on a Chromebook, so be aware of that. It is 4 questions on solving equations, so what we've done the past 2 days. Have a fantastic day, guys, and I will see you later.